This video has been created by Great IT Courses. It's a part of a mathematics course that will teach you mathematics step by step from basic algebra all the way up to calculus. For more information or subscribe to the course, please read the video description. Thank you. So in this video we want to talk about the slope of a straight line. In the previous video I gave you a general overview of the equation of a line and the y-intercept and the slope of the line and the whole story. But in this video we want to basically concentrate on the slope of the line. Now let's see what the slope of a line means. Now let's consider, for example, the line y is equal to 0. Y is equal to 0 is basically a line that lies exactly on the x-axis. As you can see, this is the color of the line. I can change it if it's required. Let's see. So this is the line now. I think you can see that better now. So this is the line, and now the line f of x or y is equal to 0. It lies exactly on the x-axis. And let's make it, for example, f of x is equal to x. The line f of x is equal to x is a line that basically slants towards the right, and this you can see how steep the line is. Now let's make it, for example, f of x is equal to 2x, and the line gets steeper. Let's make it 3x. It gets steeper. Let's make it, for example, 4x. It gets steeper. As you can see, the line is the line in this case, it has a pivot, and it's pivoting on this point 0, 0, and as I'm increasing the slope of the line, which is the number I'm changing here, it's just that the top part of this line is just getting closer and closer to the positive side, of the y-axis. You can see that now happens. Or if I make this 10x, you can see that it got even closer. Or if I make this 20x, it got closer to it got steeper. It's pivoting on this point, and it got closer and closer to the y-axis. Now let's make it 200x. And you might think that it's on the y-axis, but it's not. It just got very, very close to the y-axis. Let me see. Let me show you what I mean by that. This calculator sometimes so if I can show you the top of this graph, hopefully, so you can see that the line is not exactly on the y-axis. It's getting close and close and close, and on the top of this graph right now it's showing me that the y value is 6,000. So the y's have gotten so large over here. Now this calculator doesn't work properly. Okay, so now you can see that. You can see that now it's not touching the y-axis. Anyway, so now the slope of the line is 200. Now let's change it back to 1 and see what happens here. Now the value is 1. And let's try a few more values here. For example, let's say let's make the number -1, or minus 1 into x, which is minus x. And now you can see that the line is slanted towards the left, and it's still pivoting on the point 0, 0. And let's make it -3. It got steeper, and the top part of it is just pivoting on the same point. The top part is just getting closer to the positive side of the y-axis. Make it 4, it just got closer. Make it 30, -30, got closer. But still it's just slanted towards the left, so that is a negative slope. If I make this positive 30, then it has a positive slope, and it's slanted towards the right. So that's basically what the slope of a line is. This is basically this number, the coefficient of x. Now let's make this 2 to make things simpler. And I told you before that the slope of the line is essentially sometimes called the rise over run. And rise over run basically means that you can take any 2 points on the right on the line and then compare them as far as the rise and run are concerned. For example, let's take this point 0, 0 and this point 1, 2, this point over here. Now the point 0, 0 at point 0, 0, the y value is 0. At point 1, 2, the y value is 2. So now if you want to compare the rise of this point with respect to this point, it's basically 2 minus 0, which is 2. Now about the run basically tells you how far away the 2 points are, the 2 points that you're comparing to each other, how far away they are on the x-axis. For example, this point 1, 2 is basically the x component of the point is 1, right here on the x-axis. My first point was 0, 0, and the x component of it is 0. So you can subtract 1 from 0 or 0 from 1, that doesn't matter. Basically 1 minus 0 is equal to 1. So that means that my run is 1 and my rise is 2. So now rise over run, which is 2 divided by 1, is equal to 2. And that is the number 2 over here, which is the slope of my line. Now if I make this, the slope of this line, make it 1 and draw the graph again, you can see that, for example, taking this point 1, 1 and 0, 0 and compare them together. This is the run of the point. This is just one grid block. This is just going through the same grid block, the line I mean. Now the rise of the rise of the line is equal to the run of the line. This is 1 and this is 1. So 1 over 1 is equal to 1. So that's basically the meaning of a slope of a line. Now let's make this minus 1. Now you can see that I still have the same rise and run. My rise is 1 and my run is 1 as well. So 1 over 1 is equal to 1, but the value is negative, and so the line is slanted towards the left. We will find out more about this later. You don't have to worry about the negative and positive. It's just important that you understand that when you, for example, take this point on this line and take this point on this line and compare the rise over run of these 2 points. Now, right now the rise is 1, the run is 1, so 1 over 1 is equal to 1, and that's the value you get over here. When it's a negative value, the line is just slanted towards the left. When, on the other hand, it's a positive value, the line is just slanted towards the right. And the more you increase this value, you're just basically increasing the rise over the run. You can see that now you can see that the rise is, for example, taking this point and the origin. You can see that your rise is 1, 2, 3, 4, 5 units over 1 unit. So 5 over 1 is basically 5. If I make it 10, then the rise would be 10 over 1, which is 10. If I make it, for example, 3 divided by 2, the rise would be 3, the run would be 2, and then, or you could think of it as the rise as 1.5 and the run 1, and so the line would be a little steeper than f of x is equal to 1x. So that's you can see that it's not on the point it used to be. It's a little steeper than that. So that's the whole story. And let me show you on this graph as well. So right now this is the point that I have here. This is the line that I have here, and I can, for example, take this point on the line and take this point on the line and just compare them together. And let me call this, for example, the coordinates of this point the coordinates of this line x2 and x1, and let me call the coordinates of this point x1 and, no, I made a mistake, I'm sorry, x2 and y2, x2 and y2, and this is x1 and y1. Now this line, if I wanted to compute the rise over run of this line of these 2 points and compare them together, so this line here, my y is 0, here my y is 1, so my rise is basically 1. And so that's basically what I'm saying is I'm writing y2 minus y1, which is equal to 1 in this case. Now the run of these two points compared together is basically x2, how far away the point x2 is from x1, and it would be x2 minus x1, and it would be 1 minus 0, which is equal to 1. And here again I have the same story, 1 minus 0, and this would be 1 over 1, which is equal to 1. That is equal to the slope of a line, which is denoted by m. So to sum things up, your m, or the slope of a line, is always equal to, you take any 2 points on the line, any 2 points, as long as you're consistent with your choice of the points. You can take any 2 points on the line and compare the y coordinates of the 2 points and write them in the numerator as y2 minus y1, and compare the x components of the 2 points and write them in the denominator. And when you evaluate this fraction, you are basically computing the slope of your line, and that is basically the meaning of the slope of your line. So in the next video we're going to do some examples on how to basically find the how to compute how to compute the slope of a few lines, but first you need to understand, you needed to understand the concept. I'll see you in the next video.